In this video, I'm going to demonstrate how you can solve mathematical problems regarding the concept of fractions, decimals, and percentages. So there will be a mixture of these three concepts in a mathematical problem, and I'll attempt to solve these problems. So let's jump straight in with the calculator intro. If you go to the Save My Exams platform and go to the topic questions, home, IGCSE, maths, Excel topic questions, and go to the first topic, number and number system, and the first subtopic, or the not the first subtopic, but this topic, which is fractions, decimals, and percentages. So we already discussed fractions and percentages individually. So in this topic, there will be a combination of fractions, percentages, and also decimals. So there will be a combination of different concepts in these problems. So if we open this in a new tab, I've already opened this in a new tab. So we'll focus on medium level problems as usual. So I'll focus on the first problem. So let's read it. So it says Mr. Brown and his two children are going to London by train. So an adult ticket costs 24 pounds. A child ticket costs 12 pounds. So Mr. Brown has a family rail card. So this rail card gives or the commissions 1/3 of the adult tickets. So this is a fraction. And 60% of child tickets. So this is a percentage. So there is a combination of fraction and percentage in this problem, in this descriptive problem. So the commissions are 1/3 of adult tickets and 60% of child tickets. So Mr. Brown is one adult and he has two children. So you have to work out the total cost that Mr. Brown has to incur using this family rail card. So if I open in a new tab, so what is the cost of an adult ticket? So let's figure out what is the cost of adult and child ticket after the commission. Before the commission is 24. What is after the commission? So what is the commission? 1/3 of 24, right? So this is the commission, which is 8 pounds is the commission. So what is the actual cost of an adult ticket after the commission, which is 16 pounds after the commission. And what is the cost of a child ticket before the commission? Before the commission is 12, right? So before the commission is 12 and 60% is off. So 60% is can also be denoted as 6 by 10, or 60 by 100 is 6 by 10. Okay, so what is this? If we divide both numerator and denominator by 2, we get what? 2 3s are 6, 2 5s are 10, or 3 by 5. So 3 multiplied by 12 is 36 divided by 5. So 36 by 5, which is roughly around 7 pounds. So this is the commission. So what is the cost of a child ticket? 12 minus 36 by 5, right? So this is what? If we do a simplification of these fractions, so 5 is common, so 12 5s are 60 minus 5 divided by 5 is 1 into 36, which is 36, right? So this is what? 24 by 5, which is roughly around 5 pounds. Okay, this is roughly around 5 pounds. So this is the this is what? This is the child ticket cost after the commission, and this is the adult ticket cost after the commission. So Mr. Brown is one adult and he has two children. So for one adult, he has to incur after the commission 16. If he uses the commission the rail card, it's 16, and for his two children is going to be 2 multiplied by this cost, which is 5 pounds after the commission. So this is like somewhere around 10 pounds. So the total cost is 16 plus 10, 16 plus 10, which is around 26, because we had a rough estimation in this one. It's around 4.95, so it's going to be around 25 to 26 pounds. This is the cost that Mr. Brown will have to incur for his as an adult and his two children after the use of the rail card commission. If I now focus on problem number 2 of the medium category, it says you have to write these numbers in the order of size. There are 4 numbers given and some dots given over. So this is a concept called recurring numbers. So I'll briefly give an overview of what is a recurring number. So there are 4 numbers given here, and we have to start with the smallest number, and we have to write the numbers in order of size. So if I just go to Google and write what is a recurring number in mathematics. So recurring decimal numbers are those numbers that keep on repeating the same value after the decimal point. So for example, let's say the numbers, let's say one number is 3. So this 3 repeats forever, 0.333. Okay, so let's give an example. So in terms of the dots, let's say a number, if I use my pen tool, let's say 0.3. Okay, so if the dot is given over 3, this means that this digit 3 repeats itself forever. So this is like 0.333 ... and it goes on. Okay, so this is the concept of a recurring number. So if I focus on now the problem, so there are 4 numbers given. So you have to write all of these 4 are recurring numbers. So you have to write these numbers in order of size, starting with the smallest. So smallest to largest recurring numbers. So let's focus on the first number, which is 0.246 with dots given over 4 and 6. So the first number is 0.246 with dots given over 4 and 6. So this number can be represented as what? Because dots is given over 4 and 6, so 4 and 6 will repeat forever. So this will be like 0.246 like this, and it will go on. So 46 is the recurring pattern because 4 and 6 have the dots over it. Okay, so then the second number is 0.246 with only dot is given over 6. So 0.246 with the only dot given over 6. So this is a number that will have a recurring pattern over what? 0.24, and this 6 will repeat itself. 6, 6, 6, and so on. So this is the second number. What is the third number? 0.246 with dots given over 2 and 6. So 0.246 with dots given over 2 and 6. So this will be represented as what? 0, because dots is given over 2 and 6. So 2 and 6 will be repeated. So 0.246. Okay. So 2 and 6 will be repeated. So 2, 6, 2, 6 in this way. Okay, so 2, 6 will be the recurring pattern. Okay, so this is the recurring pattern. And then if I look at the fourth problem, which is 0.246, this is just 0.246 given. Okay, so this is the 246. There is no recurring pattern here. So this is 0.246, just plain 0.246. So you have to now write these numbers from smallest to largest. Okay, you have to write these numbers in the order of size, starting with the smallest number. So out of these 4, this number, this number, this number, and this number. So we can compare side by side these numbers. So what is the smallest number?
So 0.246, 464646, 0.24666, and 0.246, then 26, 26, 26 in this way. And then there is 0.246, and it's 000 basically, because there is no numbers after that. So what is the smallest number here? So if you look
at the smallest number, what is the smallest number given? 0. So it starts with 4, 6 here, the recurring pattern, and this starts with 2, 6. So this number is obviously smaller than this number. Okay, and here it starts with 666. So this number is greater than this number, and this number is 0.246 then 000. So this is obviously 0.246 is the 246 000. This is the smallest. Then it's 0.246 262626, this number 0.246. Then there is 26 recurring pattern, 262626 dot dot dot. Then there is 0.246 4646, this one, because 46 is less than 66, so 46 is the third number. 0.246. Then there is a recurring pattern 4646 dot dot dot. And then the biggest number here is this number, which is 0.24666. 0.24666, and this is recurring. Okay, so this is the order. This is the smallest and this is the largest. So this is the order, smallest to largest. Now if I focus on problem number 3 of the medium category of the topic fractions, decimals and percentages. So let's read the question. It says you have to prove that the recurring decimal 0.36 and the 2 dots over 3 and 6 is equal to a fraction 4 by 11. So if I write the fraction, let me use the pen tool. So 4 by 11, you have to prove that 4 by 11 is what? 0.36, a recurring number with dots over 3 and 6. So let's check how we can solve the fraction 4 by 11. So what is 4 by 11? 4 by 11 is basically what? If I divide 11 by 40, so 4 by 11 is basically what? If I divide 11 by 40, so 11 3 is a there is a point, because I added an extra 0, I added a point here, a dot. Okay, so 0.3 basically, 0.3, right? 11 into 0.3 is what? So because I added an extra 0, I added a dot, so 11 3 is a 33, right? So what is left? 7. So if we add, this is a formula, this is how you can deal with fractions. So if I add an extra 0, now here 7 0, so 11 6 is a 66, right? So 70 minus 66 is 4, and if I add another 0 here, okay, if I add another 0, so 11 3 is a, again 11 3 is a 33, and we get 7, and we add another 0, 11 6 is a 66, right? So we get 4 here, and again it goes back. If we add another 0, it goes back to 40, right? So as we can see, the remainder here is 0.3636, and it will continue. So this is the same as 0.36, this recurring number. So this is how you can show that this fraction, when I add extra 0 and to divide by 11, then we go and proceed further, we can see that remaining number is what? Not the remaining number, but the resultant is what? 0.363636. So this is what we have to prove the left hand side and the right hand side. Now I'll focus on problem number 6. So 4 and 5 are very similar to problem 3, so you can figure that out. So I'll focus on problem number 6. So let's read the question. So it says the people working for a company work either in team A or in team B. So there is no other team, only team A or team B, and all the people are work either for team A or team B. So the number of people in team A is 2, or the ratio of the number of people in team A by the number of people in team B is 3 by 4. So 4/5 of team A work full time, 24% of team B work full time. So you can see there is a fraction and there is a percentage here, a mix of fraction and percentage in this descriptive problem. So work out what fraction of the people working for the company work full time. Give you a fraction in its simplest form. So what fraction of the people, what is the requirement? The fraction of people working for company working full time. So the fraction of people that work full time in the company. So if I use my pen tool, so team A is to team B, the number of people working for team A by the number of people working for team B is what? 3:4. Okay, so it's 3:4. So let's say number of people is 3n is to 4n. Now it's the same because 3n is to 4n is basically what? 3n by 4n, which is effectively 3 by 4, right? So we can write 3n by 4n. Okay, so what is the total? If I represent the total as t, the total number is what? 3n plus 4n, which is 7n. This is the total number of people working in that company. So 4/5 of team A work full time. So 4/5 of team A. So team A is what? Thrice n, right? So 4/5 of thrice n work full time. So this is what? 4 3 is 12, 12 by 5 of n. So they work full time, and 24% of team B work full time. So 24% means 24 by 100. 24% of team B. Team B is what? 4n. So 24% of team B work full time. So if I divide 4 by 100, we get what? 25, right? So 24 by 25 of n, this is what? From team B work full time. So this is from team A, the number of people from team A that work full time, and this is the number of people from team B that work full time. So what is the fraction of the people working? If we add these two, we get the total number of people working full time. So total, if we denote TF, or the total number of working people
full time is what? 12 by 5n plus 24 by 25 of n. So if we simplify this, we get what? 25, we get 25 common because 25 can be divided by 5. So 25, 5 5 is 25, 5 into 12 is what? 60. 60n plus 25 by 25 is 1, 1 into 24 is 24. So 24n. So this is what? 84n by 25. Right.
So this is the total number of people working. Okay, the working people. And what is the fraction? You have to find the fraction of people working for the company working full time. So what is the fraction in terms of the total number of people working in the company? The total number of people working in the company is what? 7n, that we figure out here, right? 7n. So what is 84n by 25 in terms of fraction or percentage of 7n? So if we divide 84n by 25, this number divided by 7n, we get the fraction. So n can be cut off, And 84 divided by 7 is what? 7 1s are 7 and 7 12s are 84. So this would be what? 12/25. This is the fraction of the people, almost 40%. I think it's 40%. So if we multiply it by 100, I think it will get if we multiply by 100, we get what? 48%, I think. Yeah, 48% of the people, or 12/25. You can denote by either fraction or percentage. Sorry, 12/25, 12 by 25. This is the percentage, or this is the fraction of the people working full time in the company. I hope you already have an idea of how you can solve mathematical problems that include the concepts of fractions, decimals, and percentages, a mixture of these concepts, and how you can approach to tackle these problems. So in the next video, I'll go through some more problems regarding a combination of these problems, the mathematical problems that include these problems. So stay tuned for that.